So there's one fact about this conference that I'm absolutely sure is true. I'm the only registered Oracle employee for this conference. I have not met any other employee, which is interesting. So we usually present at Oracle Cloud World, and we get a lot of database customers, obviously. So this is a new experience, at least for me. I'm learning a lot about Kafka. I know some little bit about Kafka, but I'm learning a lot more, so that's always nice. So welcome to this session. Good afternoon. My name is Mahesh Girkar, and I'll be talking about unifying event streaming with databases, right? And just a brief history about my own experience. I have been at Oracle for 27 years. I have always worked in the database kernel. I have been an individual contributor working in areas like buffer cache, recovery, high availability, standby databases, those types of technologies. And about 5 years back, I got an opportunity to manage the advanced queuing development team, which does queuing inside the database. So this talk is more about that team's development journey into that product and why we think unifying event streaming with databases is a good idea. So why do we want to do this, right? This statement sort of captures, oh, okay, thank you. The reason why we do this. We want the best of both the worlds. We want the best of event streaming, and we obviously believe very highly in our own database product. It makes a lot of money for us. So we want to get the database benefits to event streaming applications, right? And that, in a nutshell, is why we are doing this. And we see this theme repeating when we talk to our customers. So this is sort of the rough outline of the talk. I will talk about Kafka. It's kind of preaching to the choir here. You guys are all experts at Kafka. But this is Kafka from our perspective, right? How we view Kafka at Oracle. I'll then talk about database. It's more a refresher about what value databases bring to application development, right? And we will talk about some of the expectations that our own customers have about event streaming applications from the database. I'll then talk about transactional event queues, which is our new type of queuing framework inside the Oracle database. And we will talk about how it is compatible with Kafka, how it supports JMS, and what kind of features does it have, right? And then I'll have a series of code snippets with Kafka and JMS to sort of bring out the value of unifying event streaming and databases. And then I'll end with a couple of slides on lessons learned and reinforcing why we are doing queuing frameworks inside the database. So Kafka, right? From our perspective, Kafka, of course, it started off its journey as a distributed commit log, right? But over the years, it has added many features that start to look like database features. And take compaction, which was added fairly early on, right? So you can think of compaction, at least we think of compaction as dividing the Kafka storage logically into two parts, right? There's a part where all the messages that are still in retention stick around, and there you might have messages with, two messages for the same key because they are still in retention. And as soon as a key sort of goes out of retention because it hasn't shown up for 7 days or whatever the retention period is, if you have compaction enabled, then you remember the last value for that key in the compacted range. So that to us looks like a table with a row that you remember the row for a long time, right? Kafka also introduced transactions, right? So you can do produce a bunch of message in topic 1, message in topic 2, message in topic 3, completely different topics, and you can say I want to do this as part of a Kafka transaction, right? And then consumers have the ability to choose whether they can see messages that have been committed or not committed, et cetera, right? So again, that starts to look like consistency, right? You are looking at messages that have been committed in the context of a transaction, or you don't want to see those messages if they haven't been committed, right? Kind of like query semantics, right? If I do a query, I don't see data that is being modified by ongoing transactions. Kafka Streams, is this client-side API for Kafka that is used for analytics. And the flip side of Streams is K-table, where you remember the state of the data, right? So K-Streams, if you sort of think about conceptually, it's like a database redo log or a change log. And K-table, obviously, is like a database table. So Kafka has been going towards databases from our perspective, right? But it is still missing a lot of the messaging features, right? So these are some of the features that JMS brokers have provided for a long time, right? Rule-based subscribers, right? The ability to select a message only based on a certain rule. Priority of messages, message lookup based on predicates, correlation IDs, et cetera, properties of the payload, per message consumption state, which is kind of an important concept for JMS again, where if you process messages concurrently, then once you finish processing a certain message, you don't see that message again, right? Kafka has this concept of a watermark, which says, okay, up to this point, I have processed everything, but if you start again, you might see some messages that were delivered before, and the application has to remember the state of consumption, essentially. So many things about messaging we believe are missing in Kafka, right? And of course, there are many database features that are missing in Kafka, right? Efficient random reads, right? Trying to just run a SQL across joins, complicated SQLs with indices, right? It's not a database, so that stuff is missing. Full ACID, you will see this theme repeating. Full ACID transactions where you want to go across produce and consume, and perhaps even do some other activity, right? That is missing. Data integrity and constraints, right? I don't want to produce a message if it conflicts with something, stuff like that, right? Fine-grained access control, right? Security, fine-grained security. These things we take for granted when we talk about databases. Those are missing in Kafka, right? So let's talk about now databases and event streaming. Right? So just a little bit on databases. This is just more like a refresher slide so that the audience here remembers all the great value companies like Oracle, Microsoft, IBM, who have great database products, bring to the application developers, right? Powerful relational standards-based SQL. Take for granted with databases. ACID and distributed transactions, extremely important when you develop applications to make sure your data is consistent, there is data integrity across even when data is distributed across different data stores, right? High availability, right? You want to minimize your downtime if your production database goes down. Oracle has had features like Data Guard, right? I also manage the Data Guard team. So in case the production goes down, we want to switch the standby into a production database very quickly, and we maintain that standby really close to the production database with minimal impact on the production database. So those types of features have been available in databases for 20 plus, 30 plus years. Flexibility in development, right? Databases offer a rich set of data types, right? We have JSON, spatial, vector, graph, queue, all of that in one database. So if you are writing an application that spans multiple types, you just have to deal with the database because the database supports all of those types, right? And that sort of brings me to the point of converged databases, right? We support a converged database where we support all of these different types that are needed for your application development, right? We support many different languages. Most databases will support many different languages, C, Java, you name it, right? Python, right? Many APIs to develop your applications. And we also have special purpose-built hardware in which we are investing. Oracle has Exadata, right, which is a very, very powerful database machine that can perform queries even faster. It can do DMLs even faster and so on. So databases have been innovating for many years, and they bring to the table a lot of advantages that people today take for granted, right? And again, back to that objective slide, the goal was always to make sure these database advantages come to event streaming, right? That has been our objective all along. So what do event streaming customers, so we talk to customers, database customers who are interested in building event streaming applications. What do they want from us? Well, they want ACID semantics. They want exactly one semantics, right? They want to lower their operational costs. They don't want to deploy a Kafka broker and an Oracle database. They are already deploying an Oracle database. So if we can give them the event streaming platform inside the database, they don't need another set of Kafka administrators or another set of machines to run your Kafka clusters, right? So, and of course, they want security, disaster recovery, and scalability, and so on. So the right logical way from our perspective is to build event streaming in the database. Right? So I hope I have sort of convincing you that this is a good value proposition, especially if you're already deploying databases. Right? A little bit more on the multi-model application architecture. So there's one way to sort of write an application that uses different types is to have special purpose databases for each type. Right? But then you run into this problem of data consistency, right? What if your key value database or an in-memory database, what if that crashed and you end up losing some data? How is now that data consistent with the rest of the databases? This becomes a very difficult problem, right? And you have to, as an application developer, you would have to manage that concept of data consistency for your application, which can be challenging, right? But when you have all the types supported in a single database or a converged database, right, it becomes much easier because even if that database loses some data, it is all still consistent as of that point in time, right? So that's the reason why we believe the multi-model single database, converged database, is the right way to go. And to drill this a little bit further, the analogy is that of a smartphone, right? Many years back, people used mobile phones just to receive calls and make calls. Then we started using them for pictures and video and maps and you name it. We could do pretty much everything now on the phone these days, right? And the converged database with a single database supporting all the types is kind of like the smartphone of databases. So if you develop a new type, it goes into the converged database. And the cross-functional aspects of that type with other types just come for free, right? You are, again, getting the data consistency for the new type and so on. So This is why we believe this is a good architecture for databases, right? Let me talk about a little bit about transactional event queue, which is our queuing framework inside the database. Now, Oracle has had a product called advanced queuing. Some of you might know that. That's a disk-based queuing system, and we have many customers who use that. And some years back, we worked on a new architecture for the queuing product inside the database, which we are calling transactional event queue, right? So what is a transactional event queue? Again, it's an Oracle database that supports a queuing framework. We support both the Kafka Java APIs as well as it's a JMS broker. So the same queue can be configured, if you will, as a Kafka topic or as a JMS topic or destination, right? We support both of these APIs. A transactional event queue, you can think of it as a logical collection of event streams. And an event stream essentially is a collection of table partitions. These are database table partitions, right? So we use, in Oracle, there's something called system partitioning, which is a very efficient way of managing partitions. And so we leverage that to the fullest, right? So we can drop partitions, add partitions very quickly to shrink or extend the event streams, right? These event streams are in memory so that when you have messages come into the event stream, they are accessed very efficiently. They are produced very quickly, they are consumed very quickly, and so on, right? We have a bunch of libraries to access the transactional event queue. You can write it in the Kafka Java APIs that you know. We support those. We support JMS. We support REST, PL SQL, Python, Java, C, and Node.js. All of these can be used to develop your applications against the transactional event queue that is residing inside an Oracle database, right? We allow features like queue-to-queue propagation. If you want to propagate messages from one queue to another queue in another database, it's very easy to set that up. We also have connectors to a real Kafka broker. So you can move these messages from a transactional event queue to a Kafka broker or bring messages from Kafka into the transactional event queue. So transactional event queues are very high-performance, scalable queuing system, event streaming system inside the database. And it is architecturally very similar to Kafka. Just like Kafka has topics, we have event streams. Kafka has consumer groups. I believe we have subscribers. We call them subscribers, right? A Kafka broker to us is a node of a real application clustered database. So Oracle has a clustered database where you can have a shared disk with multiple nodes accessing it. We call it RAC, or real application clusters. So a Kafka broker is emulated as a node of a real application cluster, right? So you can simply, with the Kafka properties, if you wanted to connect to a Kafka broker, you would say something like this: bootstrap servers, whatever, Kafka :9092. To connect to an Oracle database, you would just change that to the location of the Oracle database. And then the rest of the Kafka Java APIs just work seamlessly, right? So this is, again, a very now remember this, the Kafka topics are inside the database, saved inside a transactional event queue. So they are very architecturally very similar. Now, historically, I mean, the development of transactional event queue started around the same time Kafka was ongoing. So, and it is not a surprise in some sense that the architecture looks very similar, right? Now, we do have this Kafka Java client for transactional event queue. I mentioned that earlier, and that is available for customers to use to try out our Kafka Java APIs against an Oracle database. Now, one thing I wanted to mention, your Kafka client or a JMS client has a database connection. It's just a standard database connection. Just remember that. That is going to be an important aspect when we talk about the next set of slides. So let me now sort of try and highlight what you get when you have a queuing or an event streaming framework inside the database, right? Let's take a look at a Kafka transactional producer. So this is a code snippet of a Kafka application that is trying to produce a message, right? But we also want to perform some DML on some table when we produce that message. And we want to ensure atomicity, ACID, across the produce activity and the DML activity, right? Because the Kafka client is a database connection underneath, we can leverage that and essentially expose just the local database transactions to your application. And this is what this example is showing here. So basically, you put a property, Oracle-specific property, to say, I'm a transactional producer. And then, given the producer object, you call this API, which is Oracle-specific, to get back a database connection. On that connection, you can do your DML activity. This API here is just doing some insert, update, delete, whatever you want. It has nothing to do with Kafka topics or anything. And you can also do a send of that message on the topic, on the Kafka topic. And when you do a commit, the whole thing is one ACID transaction. You don't have to worry. If you crash, the whole thing will roll back, because this is just database transactions and ACID, right? Let's take a look at transactional consumer. Imagine you have a case of, you want to consume something, do some processing, and then commit. And if you fail, you want that message to go back as if it has never been consumed. So you don't have to maintain any state. This is, again, just basic database 101, right? The same thing. You create your consumer record, and you poll for your messages. So that's a standard poll call in Kafka, right? From the consumer object, you get your database connection, and then you process the record using the database connection, and then you do the commit. Again, you're doing things in the confines of a single database transaction, right? This is a slightly more complicated example, and it becomes a busy slide because of that, but the idea is still simple. You want to now consume from a topic, do some processing of tables, which your application might need to update some tables. Then you want to produce on another topic. And you want to do the whole thing in the confines of a single transaction. So now you're making things more complex, right? So you again start off with a producer, which is a transactional producer, which is true. You get back the database connection, right? And you can then you create the database connection from the consumer object. I apologize. And then the producer object you create from the same database connection. So now your producer object and consumer object are tied to the hip with the database connection, right? And then on the consumer object, you can do a poll, get some records, and then you can do any DML you want on the database connection. And then on the producer object, which has the same database connection as the consumer, you can do a send to produce things on various topics, and then do a commit. This is sort of, again, bringing the ACID advantage, the ACID transaction property advantage, to queuing applications, to event streaming applications. It's somewhat more complicated. If you fail, the whole thing will roll back. It's as if you never produced a message. It's as if you never consumed a message, as if you never did the DML, just like local transactions. Similarly, you can do the same thing with JMS, because transactional event queue supports both Kafka APIs as well as JMS. It also has its own proprietary APIs, Oracle-centric APIs, right? So with JMS, again, it's the same thing. You have a JMS session. From the JMS session, you can get a database connection. And on the database connection, you can do the processing of insert, DML, whatever. Right? Consumer example with JMS, exactly the same idea. You have a JMS session on which you did a receive. You can get the database connection from it, and then do a DML activity, and then a commit. It's a very powerful concept. So you don't have to worry about the consistency of your data with your database and what is happening with Kafka. This is that more complicated example that I was telling you with Kafka, but with JMS. You're trying to receive on a JMS topic, but you also want to get the database connection and create a producer object on that database, from that database session, right? And do the send activity. Same idea. So now you're doing receive, DML, produce in the confines of a local transaction. Now, you might say, well, OK, that's great. What about REST, right? REST is, again, very popular, right? Now, REST is interesting because REST is stateless. So every time I make a REST call and do a post, it auto-commits. I cannot remember. With a transaction where you're doing multiple activities, right, you have to remember the state of what's going on inside the database. So this was a problem for us for obvious reasons, because we had to work in the confine, so we couldn't do things like produce a REST call, do a DML REST call. Guess what? Those two are two different transactions, because these are REST calls, right? So we couldn't do that, right? So we came up recently, and the reason I bring this example up is because I want to state this part here, which is database advantages that we get from new innovations. We can inherit it for our event streaming applications, right? So we did recently a new feature called sessionless transactions. And in a sessionless transaction, you can do a REST call and say, do some DML activity, and you can say suspend it. You start a transaction saying, I want to start a sessionless transaction. It's almost like XA or 2PC, but it behaves slightly differently, right? So you say, I want to start a sessionless transaction. That's a REST call, and you get some kind of a transaction identifier. Then you can do any kind of REST call where you do DML with that transaction identifier. You can do a produce, consume, using our Oracle Relational Data Services, which is another product which allows you to build REST calls which wrap around your produce calls, consume calls, and so on. So when you make that REST call with that sessionless transaction identifier, you're continuing that transaction. Right? Every time you do it, you can say suspend, suspend, suspend. Every time you finish something, you say suspend. So that transaction is still active across all of these REST calls. And eventually, you can make a REST call and say, commit this transaction. So even though you're now doing REST calls, you can still do transactional activity. The same examples that you saw with Kafka and JMS, you can do all of them across multiple REST calls with sessionless transactions. It's very powerful. So the point, again, is any new innovation that Oracle comes up with in the future, we have a good chance of leveraging that when we have all of these types supported inside the database. So this is sort of, I'm trying to summarize now, what did we learn from all of this exercise that we have been doing, building queuing systems inside the database? We learned to use existing database infrastructure whenever appropriate, right? So partition table, partitioned indices, and all the tricks that databases have developed over the years, we leverage that, right? Of course, ACID transactions, crash recovery, high availability, you name it, right? So all of these features of the database, we leverage that to their fullest. We built and adapt as needed. Certain things were not there in the database. So So we created a message cache component that is slightly different from the buffer cache, the traditional buffer cache component, for the event streams that were maintained inside the cache, right? We had to do things like, because we had to work with real application clusters, we had to move messages from one node to another, so we had to develop code for that, right? So certain things, obviously, we had to do new, right? When we did logical replication, we needed to create a concept of an active queue, passive queue, and so on. So anything that was not part of the database that was needed for the queuing product, absolutely, you have to build it, right? And then leverage advanced features. There's a bunch of features like the purpose-built hardware like Exadata, in-memory execution using a rules engine, which is another package that we have for faster execution of SQL, et cetera. So we use that whenever we can, right? And I want to leave you with this slide again. This is sort of, again, summarizes, again, the value proposition, right? You get high availability, consistent state, simplified deployment. You don't have to deploy yet another Kafka broker or yet another JMS broker, because Oracle is the Kafka broker. Oracle is the JMS broker, right? A simplified development, one database for all your types. Data is consistent. You can do transactions across all of your types, right? And you get high availability. If in case your production goes down, you can go to your standby and convert that into a production database, and you get all of your data that was there at the production. So that's the sort of the journey that we have had with the advanced queuing team. And I hope that this message resonates with this audience. I normally talk in front of database developers where I might have just one slide on this, but I think this is the Kafka community. I'm sure you guys deal with databases as well, but for you, Kafka is the central, is your main world. For us, it's the database. So there is this whole paradigm shift that I think is happening with Kafka. Sort of, you saw the talk that Jay Krebs gave, right, in the keynote, right? He was talking about table flow and how you can bring streaming data directly as tables, run Flink SQL, again, SQL, databases, Flink SQLs, do streaming SQL, analytics. So I think there's a lot of values that databases bring to streaming, and we believe building that right into the database is the right value proposition, is the right way to go. And with that, I'll end my talk. Thank you. If there are any questions, I'll be happy to answer them.
Hello?
Yeah.
So does this transactional event queue support native JSONs or a complex JSON structure?
Yes. So the payload can be anything. The payload can be JSON, logs, anything. Yeah.
Okay. So is it possible to even create a business object that is of a nested JSON and export or utilize as a same one of the queue of a topic of Kafka? Because generally we utilize a connector to bring that data.
Yeah, so JSON is JSON. Oracle supports the JSON type. And you can create a transactional event queue where the payload is JSON. Now, what was your other question about moving it to Kafka? You want to move the...
The real business use case is, suppose if data moves, it is an event in a database or ERP system of Oracle, and that has to get moved to the centralized Kafka.
Okay.
So it will be act like a centralized nervous system. And as we are said, it is possible to create a nested JSON. So it should be act like a one another topic that can be directly integrated to Kafka.
Yeah, so we support Kafka connectors. That was on one of the slides. So you can move data from transactional event queue into Kafka. If your data is already in tables, there are other products that can move the data into Kafka. I think, again, in the keynote, that Oracle Xstreams connector was mentioned, right? So that can also, I think, help you move data into Kafka. I don't know if that supports JSON, though. That part I don't know. But certainly, if you use our connector, you can move it from transactional event queue into Kafka, if that's your question. Okay? All right.
Yeah, so like when we use simple Kafka, we have some throughput and latency, right? So what is the same if we use this Kafka queue
It's a
integrated
very
with
good
Oracle?
question, yeah. So the question is on, let me generalize your question a little bit. How does this compare from a performance perspective with a Kafka broker deployment, right? Now, this feature is in the database. The database is actually fairly heavy because it has to do a lot of things. And especially when it does transactional aspects, the call stack for a produce or a consume can be quite deep, whereas a Kafka produce and a consume call stack is fairly small. So when you produce and consume in Kafka, you can do a lot more than when you try and produce and consume when Kafka is in the database. But we are not targeting like the really, most of our customers are very happy with 2,000, 3,000 messages a second, which we can easily do. We can go up to, with transactional event queues, up to 20,000 messages a second. So we have done some performance studies like that. Again, your mileage will vary depending on the kind of machines you have bought and things like that, and how you configure it and so on. But certainly, in terms of just raw performance, I think, we have some ways to go before we reach the Kafka performance limits. Okay?
Couple of questions from me. The transactional event queue, you have talked about the DR scenario where the data gets replicated. Would the data in these queues also get replicated to the DR instance in case of failure? Do we see the same state of this queue in the other instance?
Yeah, absolutely.
Okay. And my last question would be, this transactional event queue, is it available in all variants of the database or only in the enterprise edition?
Enterprise edition.
Only in the enterprise edition. Okay.
I believe it's only enterprise edition. I don't think we support standard edition.
Okay,
Yeah.
thank you.
But you don't need the partitioning option. So Oracle has these options, and so you don't need to buy the partitioning option to use transactional event queues. But if you create a partition table just on the side, then you need the partitioning option.
Okay, thank you.
Okay?
It's horizontally scalable, right? So how about Kafka is a horizontally scalable. So how about coming to Oracle, it's a vertical scalable.
Exadata.
So, Exadata.
That's yeah. So
how Kafka fit in that vertical scalable?
Yeah, I mean, because Exadata is just running an Oracle database, and our queues are inside the database. So you're just running the transactional event queue inside an Exadata. So it will scale vertically. If the Exadata has 128 CPU cores, we will use all of them when you do produce and consume.
Already Oracle having rack, ASM, lot of things. So about Kafka, how to performance and buffer cache and these things to tune the extra.
Yeah, that's again going back to that performance. I mean, the performance is sufficiently high right now that we have not seen any customers that will, that want sort of, they are all set for another 10 years and so on. Again, I think when you talk about performance, you have to be very careful. A lot of people say, well, I need the best, I need to drive the best, whatever, Lamborghini or etc. But you may not need it. So you have to know what your requirements are before you, make these types of decisions. I think the main thing here is the pain associated with data consistency, data integrity is understated, with some of the, because if you are just a Kafka developer and a Kafka shop, that's the last thing you think about, but then it can come back and haunt you when you have to deal with those problems. Whereas this is from day one a solution that protects your data, has data integrity, has data consistency. So whether it fits your needs for performance is something I would encourage you to evaluate, and understand it. And remember, many customers are already running a database, hopefully an Oracle database. So, so this is, it's almost like a freebie for them to try this out.
Hello.
Yeah.
My question is, like, in rack we have services, right? Like we can route connections to specific nodes. Like maybe out of a quarter node rack, I need only 2 of them to be consumed. Can that configuration be done similar for the transactional events?
You can, because when you connect, you can specify the service, and then it will connect to that particular node where the service is running. Yeah, I mean, that's just all of the standard Oracle connection aspects hold for this.
And this is from a specific version.
So transactional event queues are good to go. I mean, they have been around since 12.1, but that was like the early release. So I wouldn't encourage you to try that. But they have been very stable in 19 RU in the cloud. Yeah, we have customers in the cloud with 19 RU. Certainly 23 AI releases. You can use it. Yeah.
Okay, thank you.
Okay.
How we can able to enable this feature in Oracle 19c?
How do you enable it?
Yeah.
It's there. It's there as part of Enterprise Edition. If you set up an Oracle database, you can create a transactional event queue. You have packages to do that. You can use the JMS API to create a JMS topic, etc. So it's there. It's just like you can create a table with an Oracle database. So you can create a transactional event queue. Yeah.
What about the deletion policy? So how long this is going to be we can able to storing?
How long?
We can able to store the data in that.
Yeah, we support retention up to some time. I don't remember exactly, but it's just like Kafka and all. You can specify how long you want the data to be retained. Yeah.
Hello.
He has a question.
Hello. Yes, sir.
Yeah. Sorry, yeah.
First of all, I want to thank you to differentiate what is difference in Kafka and what you have it in Oracle. Okay. Now, my first question is, you are creating the connections, right, to send the Kafka topic. So, how much connection normally Oracle hold? Because I am from fintech, I'm working more on Oracle databases. So, when it comes to the connection pooling, so how much it supports to open the connection and closing the connection? It will be done by automatically by the databases, or how it hold the connections with respect to the database?
So connecting to the Oracle database for doing transactional event queue activity is no different from connecting to the database to do any DML activity. It's the same, you don't have to. Now, if you're using JMS API and you're writing a JMS application, JMS has this concept of a JMS session, which hides the underlying connections for you. So what we have done with this API is to expose that so you can also do DML activity. But beyond that, it's the same connection, right? So you shouldn't have to do anything weird or different to use the JMS API with an Oracle database.
Thank you.
So a couple of questions. One of the things I wanted to understand is, it looks like it's a marriage between two technologies, and both of them can scale, or they can have very independent configurations.
Right.
In our case, it seems that your database, we are making just both of them sit together and making probably the developer's life much more simple. In this, I just wanted to understand how will they become independently scalable, or can we configure them independently with respect to the event streaming versus the database?
Yeah, so obviously to use it really efficiently, you must configure the Oracle database to run very well. I mean, because it is running inside an Oracle database. But then there are certain aspects of transactional event queue itself that need to be tuned, like how many event streams do you have. This is no different from Kafka, right? If you have just 2 partitions versus 10 partitions, you can scale better with 10 partitions. So this is it's the same way with transactional event queue. So there are configuration aspects that are related to the queuing, and there are configuration aspects that are related to the database, obviously. If you have a very small buffer cache or small SGA, it may not work very well. So you have to obviously tune your, the assumption is you're already running an Oracle database and you are already an expert at tuning that database. So it has to be a nicely tuned database, and then you got to further figure out how best to tune your transactional event.
Got it. So the question was more on the lines of the scalability. For example, your database can scale very differently from your actual broker or your event topics. So is that possible in this particular case?
Yeah, absolutely, yeah. So, we can support as many topics, as many, destinations, etc. So that shouldn't be an issue, yeah.
How do you manage the transaction timeouts?
Sorry, I didn't get your question.
How do you manage the transaction timeouts?
How do I manage the what? Timeouts. Oh, for the sessionless thing. Yeah, that thing doesn't time out. There are ways to abort that transaction. It's a manual thing. So because we don't know when the next REST call will come with that sessionless transaction. So that's a good question. I don't believe there is a timeout for that. Yeah, if there is one, it's probably a very large timeout. Like yeah.
That will leave the database.
That can leave some of the rows locked. See, this is why it's a feature, but it also needs to be managed, right? So I don't know if when you start a sessionless transaction, whether timeout can be specified, okay, for committing or rolling back that thing. I can get back to you on that. I don't know. That's done by a different team.
Because I don't really see a very good use case for your sessionless transactions.
Absolutely, yeah. No, you should try it out. It's sessionless. It's a new feature in 23 AI. Yeah. So there is documentation on it. I'm sure your question will be answered. Yeah.
Thank you so much, John.
All right. Thank you, guys.